Hello everyone, I'm back. It's the Cannabis Reviewer. You just watched the video where I showed the Arduino off and talked about how I go start my workflow and all of that and all the sensors connected. First step, if you're a noob, you're a beginner, you're going to start here. You're going to learn enough about the Arduino IDE that you can feel comfortable using it. You're going to use this IDE to test all of your sensors individually to make sure that they work. You're going to do that. This is what you do first. Don't even worry about your main code. Don't worry about any of that. Make sure this works. Then what you're going to do, well, what I did, but what you're going to do is you're going to take these examples and modify them and bring them into your own code and use them in your own code. And each example will give you the code that you really need, that you're going to need, including the include statements and everything to get that to read from that sensor or write to it, depending on what you're doing. Depends on the sensor. So this one is for the BME 280 that I showed you, and I'm not going to run it or any of that stuff right now because I don't really use this IDE I did when I first got the sensors working. But once I got past the sensors working, I switched over to the Microsoft Visual Studio. So here's kind of, I said had left and right. So what I did was, on the left side, which was the hardware, I used the IDE here, the Arduino. On the right side, where I was trying to figure out logic and the function calls and passing of arguments and the glue, everything to glue it together, I used in Microsoft Visual Studio, and you'll see why as we go through it. But don't kill yourself because there's configuration. You can't just jump into Microsoft Visual Studio and it automatically works. Doesn't work like that. There's a bit of configuration with that IDE to get it set up to work with the Arduino boards. For one, it has to use this IDE. It sends commands to this IDE. And this IDE basically does the work of uploading and programming through the interface of the Visual Studio Code. So once you've got all of them working, you're going to want to grab all this code and bring it over into your work area. So let's talk about work area real quick. So what I started with, and the folders can look kind of confusing, and it's all up to you on how you decide how to separate and organize your workflow. But we'll start with Arduino code, which is basically, here the desktop is here, and we have Arduino code there. So I created a folder called Arduino code where I put a bunch of my shit in. And basically it's a toolbox, it's a collection of shit, and then I start to go from there. Some of it I was playing around with. This one I don't need. This one I was playing around with. This one is the drivers and shit for Windows, but I don't need this at all for the Mac that I'm using. This was the first attempt of just throwing shit together, getting it together, thinking I was going to use the DHT as well, and I still may go back to it. So books to read, Accelerated C++ is a good one. C++ Primer is not too bad. And so I started to use this book, and then I also used Caleb Curry's web page, and then I also did YouTube page, and then I also Googled some stuff and went that route, including the Arduino web page and their library reference. So so how do I do this? Okay, so I have a couple of folders. I first started off in CPP Primer, and I went through and got all the logic the way I thought I wanted it. This is the right side I was talking about, and I did that from within the VS Studio Code there. So you'll see stuff that says control, get high-low values, my function declaration, setting time, my structures, my actual main code, all of this stuff. These I pulled from the libraries for each individual sensor. And you may have to go to GitHub to get those. I went and pulled them from. So I installed them. I got them from GitHub, installed them in the Arduino. Which, if you don't know how to do that, I'm not going through everything. So you can go grab it in the library section. It'd be under your username, and you'll find it. I think it's under. I'm not sure what it's under. Documents or something. Just look for it. You'll find it. Or just grab it from GitHub and save it where you want. That's really up to you. So this is where I started with my logic. I did all of the sensor shit with the Arduino IDE. I made rough drafts, basically, if you will, of the glue code here. I started off thinking I was going to use structures. I ended up not using structures. And I moved to something more C-like, which are classes. So I'll show you that. So what I did first, I took that code, I created a test folder, and I started moving in the code one at a time. I had to get this, I had to get structures, and I had to get functions all together, of course. And then the first thing I did, as I talked to you guys about already, I started bringing in these sensors one at a time. And this is my code that I used to grab. I grabbed the code from the one I used for the IDE and incorporated it into my own read sensors code right here. We'll go over this a little bit more in the Visual Studio Code, but I'm trying to show you how my workflow is and how my file and folder organization is. So, and then once I got this working, for the most part, I started putting into latest working software, and you'll see 2, 3, and 4 here. And it's hard to see it like that. Let me see if I can switch it over. That might have been a mistake. Okay. I don't like that either. We'll move back to here. I don't know how you enlarge that motherfucker, though. There. Okay. Back to this. So, after I got test running, what I did was I said, okay, let's create a folder. And we'll call it latest working GROWSS software. And I actually started that, which was just those two, and then I went to version 2, and then that's where I was able to incorporate. This is basically glue logic. First thing I did, as you can see, is there is no reading of anything. So when you look at my main app, you'll see that I have preset values for those. This doesn't even have the GROWSS. I'm still using. So you see, no, there's no I know in or nothing. This is straight CPP, old school C++. Create your executable, the whole fucking 9. This is the first one, and main CPP was the main code that I used. So, and if you come down here, you'll see this is when I was using structures, but you'll see I set values right here. I set these values, whereas when you read them out, they're going to be pulled. And this whole structure has changed as I've moved forward. Then I started advancing again, created another folder, and got to a point where this was not working for me using structures, and it was because I could not pass multiple variables from a function, and I forgot about that. So I started writing classes. So let me back off. Okay, first I did test, then I did test 2, and then once I got test 2 working, I grabbed the files that I needed, and that's what you got right here. And then for test 3, I started. It was still with structures, was having trouble, so I saved it as version 3, and then I said, fuck it, I'm going to rename it, start using classes where I can pass the entire class instead of worrying about all that, and that's definitely more C++-like. And I've gotten it to the point where this right here is the latest that I have so far. Now I'm not, and I am working from within this folder though, not this. These are backups. This tells me yes, you could use GitHub, and you can do that too, and I will be posting to GitHub. This is not a collaborative effort. It's my own personal effort, and I don't feel like I want to post until I am far enough along. But you can keep track of versioning, and that's kind of what it's for, is versioning. But this is my old school way of doing it. I've been doing it for a long time, and it works. So take it for what it is. But then I can back these up. And I could back these up any way I want. Another file, another drive, Google Cloud, whatever. So we're at classes. We launched the Visual Studio, and you'll see right up here we're at classes. And it does take some time to get this configured. And I'd recommend going on YouTube and looking around. First thing you're going to need to do is install extensions. The Arduino extension, the C++, so Arduino, that's what it looks like. The C++, which is the actual library. The IntelliSense, I recommend getting, and I recommend this because this is what colors the code for you, so it makes it easier to see, and it also provides suggestions on what to type. And this is what separates this IDE from the Arduino, for sure, amongst other things. And then I was playing around with creating makefiles automatically. I ended up manually doing it myself. And then I put in a Python extension because I wrote Python, and I brought some in, and I didn't use this to debug my Python. I used a Linux box before, and you've seen those already. So once you get these extensions installed, you have to, especially these you don't do much with, but the Arduino, you have to set the Arduino software up, configuration for your board. And this is why I say start with the Arduino IDE and move to this one once you get a little experience, because it takes a little time to know. You got to run these commands from the command palette. So you type Arduino, and all of this comes up, and you're gonna set all of these for them. Well, you're not gonna set all of them, but you're gonna set the serial port. You're gonna set the board type. So we'll say serial port, and I'm connected to the USB modem. So there's that. Go back up. Change board type, and I have the Mega 2560. Boom. Okay. And you have to, once you get all this figured out, you change the baud rate, then you get it 9600, and then you select the programmer. And how did I know this programmer? I went to the Arduino IDE, and when I set that one up, as you go through, you'll set it up for your board. It's the same programmer. It's basically sending these commands to the Arduino IDE, in terms of the programming anyway. And also I think it grabs some of the libraries as well, like the wire and some of the others. So this is all the information down here that you're going to need for everything. And then you start bringing in your code. And right now I'm on test 3 with classes. I started with structures, but I changed it. I moved on. Get rid of that. So let's talk about what we got here. Now we're moving to INOs, and because we have to follow the Arduino function and main code definition, or it won't work. And that is, it's got to be a sketch, which means it's got to be an INO. You've got to have a setup to set everything up, and then you got to have a loop, and that loop is your main, what would be what would be called the main code for regular C++. So you start with this. Now, as I did before, as you know, I started with just very simple structures, which will be changed to classes eventually. I just haven't done that yet. And then the function calls, where sorry, these aren't the function calls. These are the function declarations and definitions, function definitions, not declarations. I got to get my nomenclature right. I'm still learning this shit as I go, so forgive me if I said it wrong. But function definitions are here, which is a common practice to do that. I started with structures, and you'll see that down here. I was doing light structure and exhaust fan structures, and then I had moisture structure. The problem is when I did the BME 280, the BME 280 pulls out all three values. Can't pass those values out as a return using a return in a function call because it can only pass a single value out. So that means you either got to pass by reference, or you got to pass by address, of course, same thing, or you got to use a class or something like that. So I decided to go with classes since it's more C-like, and that C++-like. And also, as you're writing your code and you're trying to solve the problem, your problem solving is gonna change in terms of how you're writing it and what you're writing. And same goes for the organization of the code and organization of the data. So we'll start back up at the top. So my definitions, and these are for all basically the ports on the Grove Pi hat. This is the version information, which I haven't even got to this yet, but it's here for a placeholder. Here's all the Blink stuff that I brought over from Python, and they're all commented out because I'm not sure if these are going to work or not, if they're in the right place, but I brought them over anyway. Blink colors, I've got these. I was using these. I got to go back and use them again. When you set alarms and shit, you want LEDs and shit to change colors. But I'm not there yet because I backed up and I went back to classes. And since I went from structures back to classes, I backed all the way up to read the BME 280 and work my way forward from there. Don't try to take on too much when you change shit. But make a backup of where you left off last that was good. So if you get to the point where you're like, fuck it, I'm scrapping this whole thing, you got something that you can go back to that at least works. This is the email stuff, which I haven't got to yet. Definite, where they're defined constants. Enable features. This will probably end up being a class. Right now it's still a structure. And this allows me to turn on and off certain features inside the code. So if I want to turn on off exhaust fan, I can do that, or the humidifier. If I don't want to see any of the humidity read out, you get the idea. Eventually, I would like to have these as control buttons on the mobile app, and this is partially why I'm using the C++ and the Arduino, so I can have more control over that. I first started going with sensor, thinking, oh, this is what I want, but this really isn't the right way to organize the data, and I didn't really understand that till I started trying to solve the problem using classes as opposed to structures and thinking about it again. And then I come to the realization, since I'm passing the entire class, it makes sense to pass, and this is why classes are important, pass everything that's very similar. So we have a current values class, for example, which have all of the current values. Makes more sense than having a sensor class, which I thought, okay, I'll read from the BME 280 sensor, and then I'll grab this shit, and then I'll read from the memory, or the moisture sensor, grab some shit, But eventually, this did not work because I needed temperature, pressure, and humidity for current value at the same time. That didn't work with this type of setup. So now class, all the values, bam. And this is nice because now I can add to it. And the structure is very similar to the struct way of doing things. This would be struct, and now it's class. You can do private and public, which you with a class that you cannot do with structures. Structures are only public. And you can also add methods to the class, which are basically your action, do shit, like small functions or that perform some kind of execution to the class. For example, I could say, and I'm not doing that yet because I'm keeping it simple, stupid is what I like to say, but I could add get the BME 280 information and whatever, and all the gets in here, and I could say, okay, current values, get blah blah blah, and I could get all that right in here, and that is an efficient way to do it. But for now, trying to keep it simple, and I want it to be easy to understand by everyone. I don't want to get too excited and too far away, where it's difficult, and I want everyone to understand what I'm doing. And same goes for highs and lows. We got high temps, low temps, high, lows, and low moistures for the soil. And these are all the old stuff.